All right, welcome back. Today we're diving into one of my favorite techniques for differential equations, and honestly, it's a real lifesaver. It's the substitution method. We're going to see how this can take some seriously gnarly-looking problems and turn them into something you can actually solve, with confidence.
You know the feeling, right? You're just staring at a DE, and you've thrown everything you have at it. You've tried separating variables. Nope. You've checked if it's exact. Nothing. It's like running straight into a brick wall. But what if? What if you didn't have to solve that problem? What if you could just change the problem into an easier one?
Well, that's the whole idea behind substitution. It's not just some other formula to cram into your brain. Think of it more like a secret weapon. It's this incredible strategy for taking a problem that looks completely impossible and, like magic, transforming it into something that's, well, not just doable, but often surprisingly simple. Now, I know what you might be thinking. Oh, great, another complicated method. But hold on, you've actually done this before, I promise. Remember U substitution from your first calculus course? You take a really messy integral, swap out a chunk of it with U, and suddenly it all just clicked. Well, we're doing the exact same thing here, just applying that same genius idea to differential equations.
Okay, so let's get into the nitty-gritty. We're going to start with a specific type of equation where this technique just works like a charm. We're talking about homogeneous equations. If you can master this blueprint, you'll have a solid foundation for tackling all sorts of substitution problems. So what in the world is a homogeneous equation? It all boils down to one simple pattern. If you can do some algebra and get your equation to look like this, y prime equals some function of only the ratio y over x, then bingo, you've got one. That little y over x term, that's the secret key we're on the lookout for.
And the best part is, once you spot that pattern, there's a recipe, a foolproof 5-step process that you can follow every single time. We're going to set a new variable, v, equal to y over x. We'll do a little differentiation, plug everything back in, and then, this is the cool part, the equation magically becomes separable. It's a system, and we're going to stick to it.
But you might be wondering, why does this even work? Is it just some random algebraic trick? Nope. There's actually a really cool geometric reason behind it. Homogeneous equations have something called radial symmetry. Basically, it means that if you draw a straight line out from the origin, the slope of the solution is the same everywhere along that line. And since y over x is, well, it's just the slope of that line from the origin, it makes perfect sense why substituting it simplifies the whole thing. It's kind of beautiful, right?
Okay, enough talk. Theory is great, but let's get our hands dirty. Let's see this recipe in action and solve some actual problems.
So here we go. Example 1. We've got xy prime equals y plus x. Now just looking at it, it doesn't immediately shout, hey, I'm homogeneous. So our first task is a bit of a puzzle. Can we manipulate this thing to get it into that special y prime equals a function of y over x form?
Turns out we absolutely can. All we have to do is divide everything by x. And look at that, y equals y over x plus 1. There's our pattern. Okay, recipe time. Step 1, substitute. Everywhere we see y over x, we put a v. Step 2, we know from our recipe that y prime becomes v plus xv. So our new equation is v plus xv equals v plus 1. And here's the magic I was talking about. See how the v on the left and the v on the right just cancel each other out? Boom, we're left with something so much simpler. xv equals 1. Now we can just separate the variables. We get dv equals dx over x. Easy to integrate, right? That gives us v equals ln absolute value of x plus c. And for the grand finale, the most important step, back substitute. Swap that v back out for y over x, and we've got our final answer. Just beautiful.
All right, you ready to level up? Let's try something a bit spicier. xy squared y prime equals x cubed plus y cubed. Yep, this one looks messy. We've got cubes, we've got squares, it's a lot. But don't get intimidated. The game plan is exactly the same. Let's just focus on getting y prime by itself and then hunt for that y over x pattern.
Okay, so after we do some dividing, we're going to run into a little algebraic puzzle. We get a term that looks like x squared over y squared. Now, how on earth do we turn that into something with y over x? Well, think about it. It's just y over x flipped over and squared, right? So we can rewrite it as y over x to the power of -2. Spotting that little algebraic flip is so crucial. It's a common place to get stuck, but it's the move that cracks this whole thing open.
And once we've done that, guess what? We're right back to our comfy 5-step recipe. The equation is now y equals y over x -2 plus y over x. Time to substitute.
The left side becomes v plus xv prime. The right side becomes v to the negative 2 plus v. And look, it happened again. The v terms cancel out, leaving us with xv prime equals v negative 2. So much cleaner. Now it's just a matter of separating variables, v squared dv equals dx over x, integrating both sides, and finally swapping v back out for y over x. See, even when the algebra at the start was a little gnarly, the recipe pulled us through right to the end.
Okay, so this whole v equals y over x thing is clearly a powerful tool. But I want you to realize that the idea of substitution is way bigger than just this one trick. This strategy of changing variables, you can adapt it to all sorts of other patterns. Let's check out a completely different kind of problem.
So let's compare. On one hand, we've got our homogeneous equations. For those, our substitution is always v equals y over x. Simple. But now, what if you see a different kind of pattern? Like maybe the expression x plus y plus 1 shows up over and over again. In a situation like that, we're not going to hunt for y over x. Our new strategy is to substitute for that whole linear chunk.
Check out this example. Y prime equals x plus y plus 1 squared. I mean, right away you can tell this is not homogeneous. There's no way you're going to wrestle a y over x out of that thing. But, do you see it? That repeated pattern? That x plus y plus 1? That's our new target. That's what we're going to substitute. Okay, so here's the plan. We'll let u equal that whole chunk, x plus y plus 1. Then we just need to differentiate it to figure out what y prime is in terms of u prime, and we plug it all in. And what happens? The whole mess transforms into u prime equals 1 plus u squared. And hey, you should recognize that one. It's a classic separable equation. The integral is just arctangent. From there, it's the same old story. Solve for u and then sub back to get our final answer. See? It's a totally different problem, a different substitution, but the core idea is exactly the same. Substitute, simplify, and solve.
So let's take a breath and recap. What's the big takeaway here? You've basically just unlocked a new superpower for your math toolkit. So let's boil it all down to a simple checklist you can use.
Okay, here's your substitution checklist. First, and most importantly, you have to spot the pattern. Are you seeing y over x all over the place, or is there some repeated linear term, like ax plus by plus c? Next, based on that pattern, you choose your weapon. V equals y over x, or u equals ax plus by plus c. Then, you just follow the steps. Substitute, differentiate, replace, separate, solve. And finally, and I'm going to say this twice because it's so easy to forget, do not forget to back substitute at the very end to get your final answer.
At the end of the day, substitution isn't just one specific trick. It's really a whole new way of thinking. It's about training yourself to look at a really hard problem and ask a simple question. Is there a different way to look at this? Is there a change of variables that can make this whole thing just fall apart and become easy? And that really makes you wonder, doesn't it? What other supposedly impossible problems are out there, just sitting around waiting for someone to find the right clever substitution to crack them wide open?